Hello folks, and welcome back to our discussion of triangles and the angles within. Yesterday we looked at the triangle angle sum theorem, and we did some practice with using the three angles of a triangle, knowing that they add up to 180, right? And so we've been doing ones where it's just one triangle, and then yesterday the problems we looked at were kind of more complicated diagrams. So today I want to go through a different theorem with you. It is one that kind of goes alongside the triangle sum theorem, and a lot of times we use them kind of hand in hand. It is called the exterior angle theorem. And the exterior angle theorem is a theorem that sometimes you could really get around using if you have the triangle sum theorem, but it's going to make your life a lot easier if you know it. Okay, so here's what it says. It says, here's the deal. If you have a triangle and you have an extended side, and we saw some diagrams like this yesterday, there is a definite relationship between this angle on the outside and the other two angles that are in the triangle. Not the angle that's right next to it, not him, but the other two angles in the triangle. Now, work with me on this. Let's think about this for a minute. We have two fun facts in our tool belt. One is that the three angles of a triangle have to add to 180 degrees, right? So if I take angle 2 plus angle 3 and I add, let's put a question mark here, and I add question mark. If I add those three things up, I should get 180 degrees, right? Facts. That's the triangle sum theorem. Okay. But I know something else too. I have another theorem. We call this a straight angle, right? We know that when two angles are right next to each other like this, that they also equal 180. We call them a linear pair. So in other words, I have this other fun fact that if I take this unknown angle and I add angle 1 to it, I'm going to get 180 degrees. Right? Now look at this. Both of these equations have some things in common, right? They both involve the unknown angle, and they both involve 180 degrees. Look what the difference is. In this equation, I have angles 2 and 3 together, adding to the question mark to make 180. Over here, it's only angle 1 being added to make 180. Right? So if I'm starting with my question mark angle and I want to get to 180, I have two choices. Either I can add angle 1 to it, that would make 180, or I could add angles 2 and 3 to it, and that would create the triangle 180. Okay. Either way, it's 180 degrees, right? So the exterior angle theorem says this. Well, if this is true, if these two combine to make 180 with question mark, and this guy combines to make 180 with question mark, then isn't it true that these two must be the same as this, right? Let me say that again. Oh my. Let's say that this is, I don't know, let's call this one 70 degrees. Okay. I therefore know that angle 1 has to be 110 degrees. It has to be, because I know that these two together make up 180 degrees. Okay. Well, I might not know what 2 and 3 are individually, but I know one thing. They add up to 110 degrees, because it has to be true that this triangle equals 180. So I have this 70 degrees taken up, that leaves 110 degrees for these two. So they have to be 110. And look, these two are 110, and it's also true that this guy out here is 110. So we call this the exterior angle theorem, and it says that if you have an exterior angle, it is always, 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 always going to be the same as the sum of the other two angles. Not the one it's right next to, but the ones that are on the other side of the triangle from it. Right? Over here they call them non-adjacent interior angles, which is really fancy for the ones that are over there, not the ones that it's right next to. Okay, so for example, if I came up here and I extended this side I would create an exterior angle right here, right? The angle it's right next to is right here. That's not the one I'm interested in. I'm interested in these two. Okay. Whatever angle's next to it, that's not the one I like. I want these other two, the ones that are on the other side, the non-adjacent. This angle is adjacent to this. I want these two that are on the other side of the triangle. It has to be true that these two add up to be exactly the same as this, because these two make 180 with this, and this angle also makes 180 with that. Right? That's called the exterior angle theorem. So down here, according to this diagram, we would say that the measure of angle 1 has to be equal to the measure of angle 2 plus the measure of angle 3. That's your exterior angle theorem. Okay, so let's do a couple problems using this theorem. All right, so notice here, we always kind of have this warning that you're about to use this theorem, because you always see this triangle with like an extended side, kind of like a triangle with a tail on it, right? So if you see a triangle with a tail on it like that, you know you have an exterior angle, right? Here's my exterior angle right here. It's 120, right? So the angle that's right next to it isn't the one I'm interested in. I could figure out how big it is if I wanted to, right? These two together are 180, so this guy's got to be 60. But that's not the question, right? The question is, how big is this angle up here, right? And there's two ways I could get at that. I could say, you know what, I'm going to use my triangle sum theorem, right? I already know if this is 120, then the angle right next to it has to be 60. So 60 and 50, that's 110, and then it's got to be add up to 180. So 180 minus the 110 leaves me with 70 degrees, right? And I know that's 70 degrees. You can do that. Right? We use the fact that these add up to 180, and we use the triangle sum theorem. And that's how we did this. We did problems similar to this yesterday. Okay. Now that we have the exterior angle theorem, though, I don't need to do that. Here's what I know. I have an exterior angle here, right? 120. It has to be the same as these two added together. Has to be. It makes 120. 120 makes 180 with this angle, and so do these. So it has to be true that these two must add up to be the same as 120. So in other words, my question mark plus 50 has to be 120. And in one step, exterior angle theorem, your question mark is 120 minus 50, also known as 70. So you can do it in those two steps, but you don't need to. You can use the triangle sum theorem. Okay, let's do another one. I'm gonna let you try this one. Okay. Ooh. Okay. All right. So again, look, you got a triangle with a tail on it, right? You've got an exterior angle and you have some interior angles. Take a moment and see if you can figure out what that question mark is equal to. Okay. Did you like my judging face while you were working on that? All right. Here's my exterior angle. He is on the outside of the triangle. So I am not interested in this angle right here. It's right next to my exterior angle. I don't care about it. I'm interested in these other two. This one and this one. I know that they have to add up to be the same as 115. So I know that question mark plus 50 has to equal 115. In other words, my question mark has to be 115 minus 50. So what's that? 115 minus 15, 35, 65? No. Yeah, 65. Mental math. Okay. All right, so in both of these problems that we just did, we're given an exterior angle and we're asked for an interior angle. Let's take a look at one like this. Again, I could do this in two steps. I don't even need the exterior angle theorem here. Right? I could avoid it if I want to. Right? They want to know what this angle is. So I can say, okay, well, triangle sum theorem, 50 and 70, that's 120. I need it to be 180, so this guy must be 180 minus 120, or 60. So this is 60, and then therefore we can say, okay, so the guy next to it, these have to add up to 180, so this must be 120. But that last calculation, I don't need to do it. I know in any triangle that if you have an exterior angle, which we do here, we have a triangle with a tail on it. Here's my exterior angle. That is going to be the same as the other two added up. Look, 70 and 50 is 120. Boom, there it is. I don't need two steps, thanks to the exterior angle theorem. All right, your turn. Try that one. Again, you got a triangle with a tail. You're given two inside. You want the one outside. Okay. Okay, so again, here's my exterior angle. I could go the long road and figure out what this angle is and then go from there to here. But I don't want to. I'm going to use my exterior angle theorem and I'm going to cut out the middleman, right? I know that this exterior angle has to be the same, not involving this angle. It's got to be the same as these two added up. So 80 and 25 is 105, and I'm done. This is 105. Okay, and again, you want to do it the long way? Do it the long way. 80 and 125 is 105, so 180 minus 105 is 75. And then you go, oh, wait, this is 75 and this is 180, so you end up doing 180 minus 75 and getting 105 again anyway. Leave out the middleman. There's no reason to use it. Okay, now there are 4 questions like this in Desmos. So now that you're finished here, head over to Desmos, do those 4 questions. I don't have to tell you what's coming next. Algebra. So enjoy your Win Wednesdays. See you soon.